Let's go solve our next task. And today we will solve the task that's called minimum path sum. We're given a grid with non-negative numbers. We have to find a path from top left to bottom right, which minimize the sum of all numbers along its path. You can only move either down or right at any point in time. And to return actually the sum. So we move 1, 3, 1, 1, 1, and we see that and we see that the sum would be 7. Because if we move like 1, 1, 4, 2, 1, the sum would be greater. So we have to return the minimum sum. All right, so here I think we can do like DFS with all possible values, with all possible moves from to right and left, and return the minimum path for some specific row and the current sum. Or for example, when we on this one, we return 1, right? And then when we on this one, we should sum the current position and plus this one that we return. And we return back and back and back. Yeah, so it's DFS with memoization. So let's do first, we should create a graph. We should create a graph. So graph would be our map, integer, and create graph from grid. So it will be our adjacency list. Then we need map that would represent I and j and integer. So it's our memo. And we need also a DFS function that would return me the minimum a number of elements that I need. And my logic would look like I have this map. It would be my graph. And I call create graph from this grid and return DFS function. With this DFS function, I know yeah, here it should be like this. Like I'm standing in some specific position and I know the next position where should I move. I think even I don't need this graph. Maybe I just need this position, then I just need my grid. Yeah. And that's it, I think. And here, if So I need I and nj. So it's point where I'm standing right now. I'll let it be ing for simplicity. And here, if I is, so I is row, right? So if I is less than 0 or I is equal to grid length, or j is equal to 0 or less than 0, or j is equal to grid length, then I just return 0 here. Okay. Then if memo get new int ij and it's not equal to null, then I just return map get from this map. Otherwise, I should move to the right, and if I is equal, so when I'm on the last position, I should return an element from this last position. So if I is equal to grid length -1 and j is equal to grid 0 length -1, then I return I'm return grid I and j, a value from this grid. Then I'm doing two moves. So this move will be to the left and this move to the right. Oh, sorry. This move to the right and this one down. Can I have zeros? Yeah, I can have zeros. Okay, then here I just return -1. Then I have result. Grid I and j, and here I should if it's -1. So how it would work, so imagine I'm here, then I go to the right, and going to the right it would be I and j +1 and grid. Go to the right, go to the right. Then I'm going to the right and I have -1 as return. So after this, so for this position I have -1 and my result would be 1. Then I go down, I'm going down, and here I get the result of, no, I'm go down, then I go right, here I have -1, then I go down, here I return 1, and so when my right is not equal to -1, then my right, otherwise 0. Then if right is equal -1, then I should int, let's say, mod. So if right is equal to -1, I take down. Otherwise, if right is not equal, otherwise if down is equal to -1, I take right. Otherwise, I take math minimum between down and right. And now I'm adding this mod to result. I put in the map position of I and j and results, and I return results. Here it will be 0, 0, and grid. Let's run it. Yeah, let's call it map. Okay, submit. Time limit exceeded, all right. What if we will do the following? We not do this one, but do kind of another logic. So we have 1, 3, 1, 3, 1, 1, 5, 1, 4, 2, 1. And when we go to the right, we just add 4, and here we add 2. Then here we select the minimum of these 2. So we choose 2 plus 5 would be 7. Then here we add 5, and we check like 5, and we select the last 6, right? Then we go here, we add 2 to 4, so it will be 6, then 6 and 7, and here we have 2, so we just add 6 to 2, and it would be 8. And here we select also the minimum. Okay, so I think this logic should work. And yeah, so let's do it. So we have this DFS, but let's create another array with grid length plus 1 and grid length plus 1. And we iterate through every point int I equals 0, I is less than grid length I plus plus, and we have another loop here with j, j, and we take an element from our grid, I and j, and yeah, so what we do here, so we have 4 zeros, and also we have another grid like this. So we start from this element, and yeah, so we take all these 2 elements and add the element from here, from this element, and our array of I plus 1 and j plus 1 would be equal to element plus array upper, so I need I and j plus 1. No, here should be mass minimum and array I plus 1 and j. And I update all these values. And after this, I should return my array last element, array length minus array length minus 1, and here as well. Let's check. Yeah, if it's 0, yeah, it's good point here. Maybe I even can get this with grid. So I first go to the right and then go down and update it, update values. Yeah, I think it's even better. So what can I do? I can iterate to the right So int I, it would be columns. It equals 0, I is less than grid length I plus plus. And here, for every grid, I start with 1. For every grid j, for the first grid, I take I and plus equal to grid 0 minus 1. So I do these two loops for column and for row. So I start with first row, here with I, 0 column, I, 0 column. And now I do this two loops with starting with first position, grid length I plus plus. Here I go from j plus plus, and for grid I j I take current element and mass minimum for upper, so it will be grid upper, it's I minus 1, and here j, and here grid I and j minus 1, and return grid length minus 1 and grid length minus 1. That's fun. Should be j. Submit. Okay, wrong answer. Output 3, expected 8. Let's check this example. So we have, let's check it. 1, 2, 5, 6, 1, 1. So we first update this with 3, this with 6, and this with 7. Here we take 6 plus 3. So 6 plus 3, it would be 8. And then I take minimum, and it should be 8. Why it's not working? Let's use this test case. Print 2D array in Java. Arrays deep to string. Deep to string. All right, so here we have 1, 3, and then 10. Why it's 10? Okay, yeah, so here's the problem. So it should be -1. Submit. And yeah, and we are done. Let's check editorial. Solutions. Yeah, so they're doing the same logic. Okay, I think that's it. Thank you very much.